Now, this illustration deals with the process for establishing an electrically safe work condition. And of course, we know that 120.5 lists this information, but notice there's been a item 7 that has been added. The purpose of change was a revision, and the revision, was made to provide information to indicate technical accuracy for testing requirements. Now remember, we previously in Article 110, reviewing 110.8A through E on page 19 of 70E, we went through the basic general principles of testing equipment for safety. Now, let's review now our notes first. Note 1 says select the proper listed and labeled tester for testing for absence of voltage phase to ground and also phase to phase. Check tester for proper operation, and we looked at that in 110.8E. But notice 120.5, the exception 1 to 7 on page 23, deals with testing the voltage for absence to lock and tag out. Now also it says you can find this same information in OSHA 1910.147D, as in dog 6. Now the informational note 2 basically informs us and tells us to check to see if the tester is of the permanently mounted and installed type. Is that the type we're using in accordance with exception 1 to 7 to 70E 120.5 on page 23. Now the third note and final note talks about test instruments used to verify that electrical equipment is de-energized and safe to work on, should be performed and evaluated in accordance with 120.5 item C on page 23. So this is testing to perform the test and evaluate to see if the voltage is absent and the system is ready to lock and tag out. Now, the next call out now is energized conductors and circuit parts and panel board being placed into electrically safe work condition per Article 120 is outlined on page 20. The detector test instrument before, after use is required. You want to make sure you check it for it being in proper operating condition in accordance with 120.5 exception 1 to 7 item 4 on page 23 and 110.8E on page 19, as you see there. Now notice this workers beginning to get ready to test for 50 volts or more. Now, there's things inside this equipment that they should check also. Just for conductor, termination right, no arcing, everything terminated right, in accordance 110.14C of the code, that those terminations are made right, is 15.1.3 of 70B, NFPA 70B, the Bible for the maintenance electrician, basically. Now, to check this insulation, you see it has a slow melt, it's baked out, so hot, the insulation is trying to separate from the copper or the aluminum. Then we should check 15.2.11 as well as 15.4.2. Check those sections out to see is the insulation, does it have kind of a gray coloring to it? Is it charcoal? Is it black, which is very dangerous? You shouldn't even switch at all under those conditions except upstream to de-energize the equipment to correct your problem. Now, the next thing we would want to check, what is the reason for installation failure? We'll go to 70B 11.9.1.2, and your information's there for the reason for installation failure. It spells it out for you in detail, so there's no misconcept of what 70B is asking you to check in that panel you see in the illustration. Now, grounding, you want to check, make sure the grounding conductor is large enough to carry any ground fault current. It's large enough to serve as a neutral, if that be the case. And remember, your table 250.102C, as in car 1, and 70E would tell you how to size that grounded conductor for ground fault, accurate ground fault path. 220.61 of the NEC would tell you how to calculate the neutral load, and you use the larger of the two. If we had equipment grounds going out, we go to table 250.122, and an equipment ground would be sized off of the circuit breaker as required by table 250.122. If it's grounded, how's it grounded? Is it a sub panel or is it the service? If it's a service, then table 250.66 would size your grounding electrode conductor if it connected to the structural steel or to a metal water pipe that is considered an electrode. Now, table 250.66 sizes the grounding electrode conductor based upon these conductors from the transformer terminating to this main. We have an excellent book, Designing Electrical Systems, Volume 2, that has a very well chapter on grounding if you're just interested in going through that, because it would that particular chapter would tell you, well, look at 70B and NFPA 70B, look at the directory. If there's more three-phase loads than single-phase loads, you better check this grounded conductor carefully. If there's more phase to neutral loads than phase to phase loads, then this neutral might be much larger than our table 250.102C1 for a grounding path for fault current to travel over. So check that out very carefully, and that's 15.9.9 to 70B. You can see that a qualified electrician that's doing maintenance, they have to know 70B where they're changing out one-on-one, such as a switch or a receptacle. You know, for example, if you were changing out a receptacle, then article or chapter 24 of 70B would refer you to Article 406 of the NEC just to change out a receptacle. What type is it? Is it a GFCI, AFCI? Is it a duplex? Is it a single? What type of receptacle is it that you're dealing with? So the maintenance electrician, knowing 70B very well, only needs to know 70E, or not 70 necessarily, excuse me, the NEC, well enough to change out one-on-one when the system is already there and you're maintaining it. So this illustration is the process for establishing an electrically safe work condition with a new item number 7 added to it to make it more complete when you're placing a piece of electrical equipment in a safe, electrically safe work condition by lock and tagging it out.